Hello, we are from Group 2. In this video, we are going to present about the element antimony. Introduction and history of antimony. As you can see in this periodic table, antimony is a chemical element with symbol Sp. It is situated in the group 15. The proton number of antimony is 51, and the neutron number is 71. While the nucleon number, which is also the sum of proton number and neutron number, is 122. Antimony is a metallic element with silvery gray appearance. We have no idea about who discovered antimony, but it may have been found as early as 3000 BCE. Antimony ore is quite common. Jabir Ibn Hayyan, born in Iran, is considered the father of chemistry. He is believed to be the first person to have refined metallic antimony. Antimony ore was ground into black eye makeup called coal, and that was used in ancient Egypt, as seen in the famous mask of Tutankhamun. This ore antimony is mentioned in an Egyptian papyrus of the 16th century BCE. Coal is still used in the Middle East and India. The etymology of our modern name of this element is all over the map, and there is no general agreement as its origin. The medieval antimonium, from which we get our modern word from, may come from the Greek antimonakos, or monkular, since many of the early alchemists were also monks, and while the pure metal itself is not super toxic, but some of the antimony's compound could also cause problems. Another popular talk of hypothetical etymology is from the Greek word antimonos, or against loneliness, or not alone, because antimony was almost always found in alloys with other metals. Anyways, somewhere along the way it became antimony. Antimony's chemical symbol Sp does not seem to match its name very well. The Latin word for antimony is stibium, from which the chemical symbol was chosen by John Jacob Berzelius. The primary ore of antimony is stibnite.
Now we are going to talk about physical properties of antimony. The atomic number of antimony is 51. The atomic mass of antimony is 121.75 grams per mole. The electron negativity according to Pauling is 1.9. The density of antimony is 6.684 gram per cm3. The melting point of antimony is 631 degrees Celsius. The boiling point of antimony is 1587 degrees Celsius. Van der Waals radius of antimony is 0.159 nanometer. The ionic radius of antimony is 0.245 nanometer. Antimony has 12 isotopes. The electronic shell of antimony is Kr4d10 5s2 5p3. The energy of first ionization of antimony is 834 kJ over mole. The energy of second ionization of antimony is 1595 kJ per mole, and the energy of third ionization of antimony is 2443 kJ per mole. Lastly, standard potential of antimony is 0.21 Volten.
Chemical properties of antimony. Now, chemical properties are usually largely determined by the valence electron of an element. So before that, let's look at the valence electron of antimony. Antimony is located on group 15 on the periodic table. Therefore, it is also known as pinicogens. Being a pinicogens, antimony would have 5 valence electrons. Since antimony has 5 valence electrons, it is able to form 3 different stable electron configurations. For the first one, antimony receive 3 electrons to complete its 5p p orbital. In this state, antimony has reached stable octet electron arrangement. Next, antimony releases 3 electrons, removing its 5p orbital. In this oxidation state, antimony is less stable than the others, listed down here. Lastly, antimony releases 5 electrons, removing its 5p orbital and 5s orbital. In this state, antimony has reached stable octet electron configuration. In this experiment, you can see that antimony is heated up to high temperature. When antimony is heated up to high temperature, it will react with the oxygen in the surrounding air to form antimony trioxide or antimony trioxide. As you can see here, the white color thing is antimony trioxide. Antimony is also able to react with halogens. Where antimony reacts with chlorine gas, it produces antimony trichloride or antimony trichloride. Antimony trichloride can further react with chlorine to produce antimony 5-chloride or antimony pentachloride. As you can see from this video, antimony powder is reacted with chlorine gas. Antimony also reacts with nitric acid to produce antimony pentoxide and nitrogen dioxide and water. From this video, we can see antimony reacts with nitric acid.
The production process of antimony. From the first slide, you can see antimony is produced from stibnite ore, which is processed into antimony metal and antimony oxide. In the second slide, I will show you its production process. The extraction of antimony will occur. It depends on quality and composition of ore. Most antimony is mined as sulfide, whereas some lower grade ores are concentrated by froth flotation, while higher grade ores are heated. They will be heated up between 500 degrees Celsius and 600 degrees Celsius. This is because the temperature at which stibnite melts and separates from the gangue minerals. Lastly, antimony can be isolated from crude antimony sulfide by reduction with scarp iron. In the third slide, you can see sulfide is converted to an oxide, whereas it is roasted and finally vaporizing the volatile antimony trioxide. Then antimony is isolated from oxide by carbothermal reduction. Lastly, lower grade ores are reduced in blast furnaces, but higher grade ores are reduced in reverberatory furnaces.
So what are the current purposes for the production of antimony? Although we do know that antimony was used by the ancient Egyptians as cosmetics in the past, are they still used in cosmetics up to this day? Here are some of the answers. Firstly, the usage of antimony in modern cosmetics have been greatly reduced. Although still used by some cultures, most cosmetic companies have stopped using antimony in their products. This is because antimony sulfide, also known as stibnite, was ground into a powder called coal, which could then be used as an eye cosmetic. Now, the contamination of coal with lead has been highlighted as a particular health concern, though there are research conflicting on this issue. Today, one of the main uses of antimony is in fire retardants for many commercial and domestic products. For example, antimony trioxide, which is used as flame retardant in children's toys. Antimony trichloride is used in the manufacturing flame-proofing compounds as well as paints, ceramic enamels, glass and pottery. Other uses include ball bearings and mixing with alloys with percentages ranging from 1 to to 20%, greatly increasing the hardness and mechanical strength of the lead. The capability to strengthen already strong alloys is its largest and most widespread use. A lead antimony alloy is used in batteries. Other uses of antimony alloys include type metal in bullets and cable sheathing. Antimony is used in the industry to make some semiconductor devices, such as infrared detectors and diodes. Antimony is used as startup neutron sources in nuclear reactors, dopants for silicon wafers in the semiconductor industry, safety matches and brake pads. Henceforth, those are some of the applications of antimony in the modern world.
Antimony toxicity. Inhalation exposure. Aerosol containing small particle composed of antimony compound with low water solubility are retained in the lung for a longer period of time than those containing larger particles with high water solubility. Oral exposure. Antimony predominantly affect the gastrointestinal system. 70 people became acutely ill after drinking lemonade containing 0.013% antimony. Most recovered within 3 hours, but in some cases recovery was not complete for several days. Other exposure from antimony compounds. Antimony was implicated in the cause of cord death or sudden infant death syndrome (SIDS). It was claimed that antimony compound used in fireproofing cord furnishing, amongst other additives, was primarily responsible for SIDS due to the action of a fungus growing on polyvinyl chloride cord mattress cover. Antimony toxicity occur either due to occupational exposure or during therapy. As a therapeutic, antimony has been mostly used for the treatment of disease. Quality control of each batch of drug produced and regular monitoring for toxicity is required when antimonials are used therapeutically.